All right, so getting ready for the properties test. First thing I want you to look at here is this general form and then this equation. And in this equation, the amplitude would be 6. This 2 right here, this 2 is telling me that the period has changed. And the general formula for that is this. And so now I stick a 2 into it for B, because this is B. And now I'm going to put in a 2 right there, so then this cancels, and this is period is pi. What does that mean? That means it gets a whole cycle done now. Instead of in 2 pi, it gets it done over the course of pi. It's a shorter time period. So basically, did this get squished or stretched? Squished. It got squished down to be, gets done with quicker. So instead, here's normal pi. And then this one gets done now with a full cycle in half the amount of time. The idea? All right. Now, if I actually was going to do this, this would be for the graphing test, but I would say here's the old numbers, 2 pi, pi over 2, and 3 pi over 2. You got to memorize those. Have you got those memorized? You good at those already? Okay. Then these all have to change to new things, and the new period is pi, so I put a pi right where the 2 pi used to be. And then this has to be half as big as it used to be, so I'm going to put over 2. This has to be half as big, so I put over 4. This has to be half as big, so I put over 4. And there we go. And I should double check to make sure I did it right. 1/4 of a pi, 2/4, which would be the same as a half of a pi, 3/4 of a pi, and 4/4 of a pi, which is 1 whole. All right, so that's just a quick reminder on that for the graphing test you're going to take eventually. All right. Question? In this case, since the period is now changed to pi, when we move it a pi, it's like nothing happened. You're right. Because when you move it over, let's say it looked like this, and real pi goes on farther and farther and farther, then when I move this over 1 pi, I'm going to move it over that far, and all of a sudden it's right on top of itself again. All right, so it's like you can't even tell it changed. All right, so next one is the +9. That's a vertical what? Is it a stretch? That's a shift. Okay, so yes, it's up 9. Good. All right, and this minus pi, does that imply right or left? Let's move to the right. That's correct. Okay. So if they asked you, what were all the changes that happened to this graph, that's the kind of question you have to answer tomorrow. Not like what is the graph look like. It's what changes did we make to the graph. Don't actually have to graph it. Yes? Good question. The order does matter, but they don't ask the question that way. They ask the question like, what's the amplitude? Or what was the, oh, by the way, this is called something special. Does anybody remember the name for it? Fancy name. Sounds like it's out of Star Trek or something. A phase shift. Very good. That's called a phase shift. Okay? Yes? Okay. All right. Moving on then. If I tell you the highest point and the lowest point of a graph, this is stuff that's kind of new, but you have to know. And you can reason it out. I could have just left you to figure this out, but I want to practice it with you a little bit. So if I tell you the highest point and the lowest point in the graph, do you get I can tell what the amplitude is from that? All right, so let's say that the highest point here is like 8. It goes up to 8, and it goes down to the lowest that this bird ever flies is 2 feet off the ground. Do you get what I'm saying? So it flies in a sinusoidal pattern, like up and down, okay, and it goes up to 8 feet off the ground, then down to 2 feet off the ground, and then back up to 8 feet, and then back down to 2 feet. Then what's the amplitude? I got an answer of 3, I got an answer of 6. What do you guys think? Think about regional pi. Regional pi goes like this. It goes up to 1 and down to 1. Negative 1, sorry. And its amplitude is what on the original? 1. Does that help you decide? All right. The amplitude is this distance right here. It's not the whole distance. If you were going to do the whole distance, you'd have to cut it in half. So the answer was 3. What is the whole distance between here and here? 6. So what's the amplitude? It's not 6. It's 3. Good thing we talked. Look at the pi one. Or, sorry, the sine one. Do you get that this distance would be 2 on sine? From the very top to the very bottom, don't you get the distance would be 2? And so the amplitude's 1. All right, well, at least you know it before the test. The worksheets, you're going to lose a few points. That's nothing compared to the test. Bill, William. Can the amplitude be negative? No, it'll always be a positive. Well, if you have the number given to you on something like this, then that is the amplitude. That's it, 6. But if you were going to look at a graph, the graph of it, if that amplitude is really 6, that means it goes up 6 here, and then it goes down 6 there. So the total distance between here and here would be 12. So the amplitude is not the total distance. The amplitude is how much from the middle point, how far up and how far down does it go. So again, if this distance was 12, then the amplitude would be 6. Okay, yes, in the back.
So if it's like a graph of the x and it doesn't go into the positives.
All right. Here's a graph that doesn't go into the positives. It's still going to look kind of like sine. Let's say this is, instead of a bird flying in the air, it's a fish swimming under the sea. Okay, and the fish swims along and he goes up to near the surface, and let's say he gets down to 3 feet below the surface. And the deepest he goes is 12 feet below the surface. Then what's the amplitude of the equation for the fish? Halfway between, and then how far up and down from there. So if I take 12 minus the 3 would be 9 total. So the total distance between here and here is 9. Then it's 4.5. Yep, amplitude would be 4.5. Half of the total. So this distance would be 4.5. And notice that I made it, it's positive. It's a, you know, the fish is not, it's all underwater. They're all negative. All right. Now there's another thing you can tell from that picture. The amplitude's one thing. The other thing is, how long is it taking to complete a cycle? Let's go back to our bird example. Let's say that this is the bird and he goes to 8 feet high off the ground and 2 feet high off the ground. That's like the y. The x is the time it takes to get there. Let's say this is at time 1 second, he's at 8 feet off the ground, and at time 2 seconds, he's at 2 feet off the ground. Okay, so in other words, it took him how long to get from here to here? 1 second. Then what's the period? How much of the period have we completed? Half of it. So therefore you just double it, and so therefore 2 seconds is the period. We'll do more practice on this, you'll get the hang of it. All right, so here's another one. Here's my fish swimming under the ocean thing. And let's say that the fish is a little slower, but he goes all the way up to 5 feet below the surface and all the way down to 25 feet below the surface. And he's at this spot right here at 4 seconds. And then it takes him a while to get to this spot. Let's say it's 24 seconds to get to that spot. All right, so then you could tell me what's the amplitude and what's the period for the function that would describe the fish swimming in a sinusoidal fashion. All right, so now amplitude. Amplitude, is that the y's, the up, down? Yep. So the amplitude would be found by these two, and so the total is what? 20? 20? Because 25 and the 5, from here is 5 and here is 25, so the total distance is 20. And so what's the amplitude? 10. Get that? Okay, then the period. All right, well, what is the period, the time it takes to complete a whole cycle? Has our fish completed a whole cycle? No, he's only done a half a cycle. Because he went from the very top to the very bottom. And so then how much longer? Well, it's going to take twice that long, right, to do a full cycle. So How long did it take our fish to get from here to here? 20 seconds, and therefore a full period would be 40 seconds. Get that? Yes?
On those worksheets, when it says graph 2 periods, do all those periods have to go off to the right or
Nope. Good question. So when it says, this is more for the graphing test, but when they ask you to graph 2 periods of a thing, here's 1 period of pi. Now I can do my other period over here, and I think it is easier, but it's up to you. If you'd rather graph that other period over here, to some extent, this is easier because whatever you numbered this by, you can just do the reverse numbering over here. You know what I mean? Like, let's say that this is 1/4 pi, and this is pi over 2, and this one's at, let's see, 1/4, 2/4, 3/4 pi, and this is at pi. Then I can just use those same exact numbers over here. So I'm actually changing my mind. I'd rather do it this way, because now I can say, oh, that one's just negative pi over 4. Get the same number from here, right? And then this one's negative pi over 2, and this one's negative 3/4 pi, and this one's negative pi. And that's 2 periods of it. But it is okay to do it either direction. You just have to have, if it says to graph 2 periods, graph 2 periods. I can't just, you know, give you part credit on these. They're right or wrong, so make sure you look through your directions. That's mostly for the graphing test, though. For the test you're taking tomorrow, negatives are the key. You got to remember when you're in the negative part of the quadrants or not. All it takes is to forget a negative, and you lost the whole point. Okay, so let's practice some of that next. This cosine graph. This is kind of your standard cosine graph. What's its amplitude? 1. Because the highest it goes is 1, and the lowest it goes is 1. The total distance is from here to here is 2, and so the amplitude is really 1. All right, has this been shifted, or is this kind of your parent one? It's the parent one. If I wanted to move it over far enough so that it would completely overlap with itself, how far would I need to shift it? 2 pi. So that would be like this. Y equals cosine of x. And then how do I shift it to the right so far that it overlaps itself? Minus 2 pi. And remember how I was saying that if you did something like minus 2 pi, that it doesn't even matter? Remember that from those other problems? And if I said minus 3 pi, then it would matter because then it goes far enough that it matters. Okay. So, on this kind of a problem, I could potentially ask you, let's say the highest point here is actually 8, and the lowest point is negative 8. And they could say, what is the what? Amplitude. And you would say 8. The total distance between them would be 16, and the amplitude would be 8. Okay, let's say I change this numbering to 2 pi over 3, and then they asked you to tell what this spot would be. It's not graphing, it's just a question about a graph. Pi over 3. If you have trouble finding half of something, multiply it by 1/2. Watch. See how the 2's cancel? See how the answer's pi over 3? Okay. All right, next thing. Say they gave you that. They could give you that and ask you, what's the period of this function? It would have started out as 2 pi because it's sine, but then it's going to change to 2 pi over 3. All right. Focus on this, please. All right, next thing. If this has been shifted, has it been shifted far enough so that it's going to overlap with itself perfectly? It would need to be shifted its period. What is its period? 2 pi over b, which is 3. 2 pi over 3 is its period. So I'm shifting it pi. That is not exactly the same as its period. Okay? So it is not being shifted far enough so that it completely overlaps with itself. All right, what else could they ask you? They could ask you, what is the phase shift? And what would you say? Just pi. That's the phase shift part right there. That's a shift. All right, next thing. Yes, question? Yep.
How far would
If you wanted something to completely overlap, then its phase shift should be exactly the same as its period. Like if you get, do you get that if I make sine like this, that's a normal sine? And if I move it over, I got to move it over far enough so that it actually completely lines up with where it used to be. I have to move it over a full period. So this guy's period was 2 pi over 3. So if this was 2 pi over 3, then shifting it over like that would completely overlap with itself.
It was like 4 pi over 3. That
If I have doubled this,
yeah.
yes. All right, moving on. This one, I'd like you to just answer 2 questions in your notes. What's its amplitude? And what would its period be? Amplitude? 2/3. The amplitude is not the negative in front of it. The negative in front of it makes the thing flip. The amplitude is how high it goes, and that's going to be a positive number. Okay? Next thing, the period. 2 pi over what? Over 1/5. Do you get how this is like a 1/5 x right here? It's the same exact thing as x over 5. So then the period is 2 pi over 1/5, which is the same as 2 pi times 5, which would be 10 pi. If you put this or this, raise your hand. Good. All right. So a lot of you didn't know what to do on that. That's a little scary. That's probably just because you didn't know that this was really 1/5 of 1/5 times x. All right. And you would not want to leave it this way because it's not simplified all the way. So 2 pi times the 5, 10 pi. All right, moving on. This one's just an old-fashioned draw me a triangle and figure out what the answer is. Now, is the answer they're asking for a number of degrees? No. Because that looks like sides, doesn't it? But it is radians, and so they've already given you the degrees by giving you that. What they want is the answer to it, which is a fraction with sides on it. What I want is the sides. The degree is already given to you. Degree is not in degrees, but it's in radians, but you get the idea. If there's pi in it, they've given you radians, so they're giving you the angle. They have given me the angle. They want the sides. All right, so now, draw me one of these. Try to figure out where to put that triangle. Label it with the degrees on it, and then you'll be able to figure out what the sides are. Because these are always going to be 30, 60, 90s. 45, 45, 90s. Or there'll be those quadrangles that are like not a triangle at all, that go straight up or straight down. And we'll talk about those in a minute. So where should this triangle be? Well, where is negative 2 pi over 3? Well, here's where you start. You always start here. And if it's negative, you're going down this way. So this arm here swings down like to there, but that's not where it is. It's at 2/3 of a pi. Well, the whole pi would have been to go all the way to here. And it's obviously not that. So it's 2/3 of a pi. So it's going to be about like that. Think about it. That's about 2/3 of the way to 1 whole pi. All right. If you like 1/6 of a pi better, because those are 30 degrees each, you could say that this is 4/6 of a pi, and then count it out like that and say, well, 1/6 of a pi is right, hold on, 1/6 of a pi would be right here, 2/6 of a pi, 3/6 of a pi, 4/6 of a pi, 5/6 of a pi. Okay, and I want the 4/6 one. So I wanted that one that was right here. So I'm going to clean this up a little bit, and then my final answer, it looks like this. And the one way you can think of it is I have 2/6 of a pi left before I get all the way here. So this is at 60 degrees. There's only one way to make this triangle. You always, from the point you have, you always go straight up or straight down. And if that's a 60, then you should know well enough that this is 30, and this must be 1, and this must be 2, and this must be square root of 3. Now, what have we got to be careful about right here? Negatives, very good. Negative and a negative. And now, my final answer is the sides. What would the sides be for sine of this? Opposite over hypotenuse. So what's the opposite? Negative root 3. And what's hypotenuse? There you go. Raise your hand if you had that one right. Okay. If you didn't, that's a R2 level question. You need to study tonight. All right. I know that it can be tricky. They really, I get that these, even though they look very simple, can be tricky. But if you didn't know where to go on this, then you haven't memorized these well enough. You got to go back to that big circle and make yourself memorize 1/6 of a pi, 2/6 of a pi, 3/6 of a pi, 4/6 of a pi, which is the same as 2/3 of a pi, 5/6 of a pi, 6/6 of a pi, etc. I gave you that before, and it is on files and links, that big chart you could memorize where all those little radian things are. All right, moving on. What is the cotangent of negative 3 pi over 4? Same idea, except it's not in the exact same angle. They gave you a slightly bigger angle. I'm going to pause while you figure that one out. Okay, I'm back. Get unfreeze my board here. Okay, so you needed to draw something a lot like last time, except it was a little bit farther. It was right in here. And that one's 3/4. Actually, that's off a little bit. I'm going to make it better. Right there. And that's 3/4 of a pi. If you know that 1/4 of a pi, again, worthy of memorizing, that's 45 degrees. You know that one? Okay. Then you know that this spot right here is 45 degrees. Because there's 3/4 of it is, I'm almost there. I'm 1/4 of the pi is left. That's this part. Get the idea? All right. So then if that's 45, then this is a 1 square root of 2. Be careful with negatives. Negative, negative. And I want the cotangent of it. Well, first of all, I want to find the tangent of it. Then I'm going to flip it. Tangent of it is opposite over adjacent. -1 over -1. And if I flip it, it's the same thing. -1 over -1. Which equals 1. Raise your hand if you had that one right. Good. Okay. Moving on. What is the sign of -2/3? That doesn't make any sense. That would have to have a pi in it if it was radians. And it would have to have a theta equals if it was the other thing. I'm not going to do that one. I'm going to do one you need to practice anyway. Sine of 270 degrees. This is that kind where you cannot draw a triangle. You should start by drawing a triangle. Now, Mr. T, you're doing something interesting, and it works. I just want you to tell, what are you doing? Yeah, I know you got the answer a different way than most people just did. So what's your way of doing it?
I didn't do anything.
Oh, you did too. I saw you look on the little thing.
No.
That's okay to... Oh, liar. Okay, anyway, you could, in theory, if you wanted to, look on the little chart that I put on files and links, and it's got all these important points on it, all the way around the circle, and 270's down here, and there's a little point down there. What point is down there? 0, -1. And why would that be important? Because then you could say, oh, sine is the y. So the answer is -1. Do you have to have a chart to know that? No. You can kind of just figure that out as long as you know where 270 is. You can use the chart if you memorize it. Seriously, that's all you have to do. All right, next one. All students take calc tells you where this point is, and once you know where the point is, you'll know whether x is positive or negative and whether y is positive or negative. So what can you say about the point x, y? Well, really what I want to know is x positive or is x negative? And is y positive or is y negative? And so tell me, what do you know about x? What do you know about y? And the last thing is, what do you know about y over x? I want you to figure out where the point is based on this info right here. Make yourself a little picture. You'll be able to tell, what do we know about x? What do we know about y? Did you hear about the hot air balloon pilot in Georgia? From one person I can tell it, I guess. Dude is up in his hot air balloon, and he is helping these three guys do a jump. They're going to jump out and do their skydiving thing. And all of a sudden, out of nowhere, this storm comes up. I mean, it comes up really quick, just like forms around them. And he's like, we were supposed to wait for a while and then jump over this big open area. But there was all these trees, and the guy sees this opening clearing, and he's like, you guys jump now. You got to get out of here because there's a storm forming. And I don't know if you know this, but you really don't want to be in a hot air balloon in the middle of a thunderstorm. Okay, that's a very, very, very scary thing. So what happens now? It's a little bit of quick problem solving. Let's say it's you. Let's say you're the guy about to jump. And this pilot knows that he is probably going to be in some serious crap in a few minutes. That's why he's saying, you guys jump. What should you do? What should you do? This is not how to survive if you're jumping out of a... no, I'm just asking, what should you do? What? That's exactly, very good. You grab the guy, that the pilot, and you jump out with him. Because that is not what they did. They jumped out like he told them to. And what happens then? Think about the physics of it. Three guys jump out of the balloon. Balloon goes whew, up in the air, and it got caught in an updraft, and he got sucked up 18,000 feet into the storm. The storm collapsed his balloon, and then he came down at 200 miles an hour in his bucket, and he crashed into some trees and he died. So the skydiver said, if I'd only known that he knew that we were in big trouble, and that's why he's saying, you guys got to jump now, because this storm is about to come in on us, he would have strapped him in, and there's a way that he could actually like clipped him in and stuff, and he would have been able to pull his chute, and would have been able to support two guys. But he didn't know that, and so he's looking back saying, why didn't I could have saved this guy's life so easy. But instead, the pilot died. It was pretty... The pilot, I don't think, I'm just guessing, the pilot didn't think of it either. The pilot probably thought, I've got to land my balloon. He wasn't thinking in terms of, like, if I don't get out of this balloon now, I'm going to die. He probably never skydived before, probably didn't even think about tying in with this other person. So, anyway, that just happened the other day, and I thought it was a good problem-solving challenge. As soon as he jump out, he knew he was going to go up. I mean, that's what they're used to that. It's not like you get, but if you go up, you just like release something in the top of the balloon, and it makes you go back down again, because it releases a lot of the hot air, right? But the problem was that when there's a giant thunderstorm, it tends to have a big updraft underneath it, and he knew this. The pilot knew that he was likely to get sucked up into the storm from the updraft of the thunderstorm that was developing. So he wasn't even thinking about. All he was thinking was, I got to get these guys out of here, because if they get out now, they'll be safe. But if they stay with me, we're going to be in for a terrible ride, So he wasn't thinking about saving himself. And if he had been, he might have thought about how to, I could just clip in with this guy, and then he gets to get out safe too. Yes? Emergency parachutes? I agree 1,000%. I would be buying a parachute. Don't know. Maybe that I don't think that's a standard thing for balloon people. Yeah, there'll be more people that'll be thinking about it. That's for sure. Yes.
Why couldn't you just like control crash? Like just try to release as much air as possible in the hot air balloon?
I know what you're saying, but remember, this thing is like a giant sail in a way, because it's a giant sphere, right? And once it gets getting sucked up by this huge updraft, he couldn't let out hot air fast enough. I know it's generally a pretty slow process. If you pull open that hole on the top and it lets out hot air, it takes a while for it to take effect, even if it's calm. You know what I mean? You don't just immediately plummet to the earth. So I think the fact that it was being pulled up too fast, it was like a giant sail being caught in the wind. It was just, whoop. Again, he went up 18,000 feet in just a matter of a couple minutes, because he was on the phone with his ground crew, like probably scared out of his mind, knowing he's probably going to die. because as soon as it goes up into that cloud and that it just, there's so much wind and stuff, it just collapsed the balloon and turned it into what they call a streamer. It means it gets all wrapped up into like this little flag thing, and then it just falls. So anyway, back to what did you figure out about these? I hope you figured out sine is negative. Students, take calc. Sine's negative, can't be here, can't be here. Where could it be negative? There or there. But tangent's got to be negative, so it can't be there either. So I must be over here. If this is where my line is, then x comma y is somewhere in there. And what can I say about x? Positive. What can I say about y? It would be negative. And then what could I say about y over x? Also known as tangent. We already knew it was negative from that. But if you just think about it, if one of these is positive and one of these is negative, and I divide them, I'm going to have a negative. All right, moving on. This is one where you draw the picture and you don't tell me the angle. It seems like you want to do that. I've done that before in class in one of my other lessons. I found the angle by accident, wasn't supposed to. I just want to know what cosecant of theta is. Well, that's one more very realistic situation you're going to run into, so give it a shot. Always start by drawing a picture. On the test, you'd only have 8 questions. This would be 1 out of your 8, right? And you got about 40 minutes to take the test, maybe more. You probably have the whole hour. So that means if you had 80 minutes, that'd be 10 minutes per question. So you got at least 5 minutes for each question. Okay, so I've given you less time than you would normally have, but so I draw my picture. Cosine is negative. Where is that? All students take calc. Where's cosine? That cosine is not negative there. Cosine's positive there. Cosine's also positive there. So it must be one of these two. And then tangent is greater than 0, so it must be down here. Raise your hand if you put your triangle in the right spot. Okay, good. Then if the triangle's in here, I don't know what the angles are and stuff. I know sides though. Cosine is ca adjacent over hypotenuse. The adjacent one is -4. The hypotenuse is 5. And I know this one, the 3, 4, 5 triangle. If I didn't know it, I could use a squared, b squared, and c squared to help figure it out. All right, so now that I got all of this stuff labeled, this is not one where I know the angles, but I don't need the angles anyway. I need what's cosecant. To do that, I need to know sine, and so which one is sine? Opposite over hypotenuse, 3 over 5. But then I flip it to get cosecant. So cosecant would be 5 over 3. And is one of those negative or not? Ah, very easy to forget, isn't it? That would be negative, so that was negative, and I remembered it just in time. I should put a negative there too. Do you feel confident on that kind? Okay, good. All right. Where is sine of theta equal to 4/5? And I don't mean what angle. Draw me a picture. What I mean is, what quadrant? All right, here we go. You should have said sine is positive here, here, and here. So it has to be in quadrant 1 or quadrant 2. Do you get the answer? Do you get that? Okay, good. Then which one is it? Well, it could be either one. It could be both. So a lot of times you have two answers. All right, next one. Where is tangent undefined? That's a little more specific. Instead of just quadrants, I can draw my picture and say tangent is only going to be undefined if it's something over 0. So that means that I must be not at a spot where I'm drawing a triangle. I must be at one of these spots. Either here, which is at 1, 0, or here, which is at 0, 1, or here, which is at -1, 0, or here, which is at 0, -1. And which one is it? Is it 0, 90, 270, 360, 180? What do you think? Tangent is undefined. Tangent is y over x. It's that over that. That's a spot where it would work. That'd be 90. And this is another spot where y over x would be undefined. And it's at 90 and 270. Raise your hand if you had it right. Good. All right. Now, if I take this one, you know how if this is an even number of pi's, then it just is going to like cancel off like it's not even there? Because that's like shifting it over right on top of itself, right? Because every time you shift it over, it's the same number as its period, 2 pi. Then the thing just, it doesn't do anything. All right, so this one is 201 pi, though, so not all of them are going to cancel. How much is left? 1 pi. So this is really a shift of pi. What kind of shift is that called? A phase shift of pi. How far is pi? It's from here to here. So I'd shift it over that far. So if my graph looks like this, shift it over that far, like that. Okay, next one. Oh, finally, we're done. Just wanted to mention that there are a couple examples of real-world questions. The tide one I think you'll understand better. If I talk about the high tide and the low tide, do you get how I'm giving you a high spot and a low spot? And from that, do you get that I could figure out the period, remember, from here to here, and say, oh, it's got to be twice that because it is only half a cycle. And I could also figure out the amplitude, which is like from here to here. And then you figure out the total distance and cut it in half, and that's your amplitude. Okay. That's all I got for you for today. Good luck on the test tomorrow.